Raj. So I spent past 7 years working in automotive sector. Since 2017, I have been working with Mercedes-Benz Research and Development India Private Limited. I work here in trucks division. Previously, I was working for Renault Nissan Technology Business Center India Private Limited, Chennai. There, I have been working in cars division. So overall, I have 7 years of experience in automotive industry, 3 years in cars, and now since 2007, I've been working in with the trucks division. So, and I before I start, I like to thank the faculty of mechanical engineering and Kumar sir for giving me this opportunity to be back with my juniors. So we start. So let's in in view of the current scenario, COVID-19, we are living in a highly unusual and weird time. So as students, many of us, you have the doubt, self-doubt regarding your academics as well as your career. So I request you to be patient because you have a very excellent faculty and your institution has been providing you like webinar series and Luminous series, and because many of the institutions are failed to provide such aids to the students. So please keep hope within you. So this time will pass, and please don't be lazy. Please prepare yourself for the upcoming examination as well as the interviews are yet to you face. So today's webinar content is displayed in this slide. So I will give you an introduction about innovations, and I will take you to a particular innovation that I am explaining here. There's a case study. There's a problem we faced with, and how we are providing a digital solution to the problem, and the features of that system or mechanism that provide the solution, and some regulations, especially that vehicle regulation category. You will not be able to find any relevant videos in YouTube or something, because it is specifically for the automobile manufacturers. The engineers, even as I speak, like me, work in this area. So as students, your focus area is relatively important in this vehicle regulation category from the perspective of a working experienced engineer. And lastly, that we define the summary of the whole webinar series. So before I move on to the topic, I would like to ask you a question. You don't need to answer that, but you have to create an image. You need to think yourself why I am asking this question, because hopefully we all have seen movies of Vijay. I really hope that you're a fan crazy about Vijay, but same thing. If you noticed Vijay with a specific director, A.R. Murugadas, there's always something, a catch or something that hooks us to their movies. Because, for example, if you consider his movie Tupaki, there will be a relative term called sleeper cells. And in the next movie, in Katti, he will be, there's another term for agriculture. And in Sarkar, there's something term called voting. So in all these movies, compared to his other movies, there will be a innovative idea that keeps hooked to us, the movie, the theme. So once you see the movie and come out of the theaters, you will spread that word of mouth. You will be speaking about sleeper cells, so that other person will be curious about to know what is sleeper cells and something like that. So innovations can be in every industry. It is not definite that it is particularly in manufacturing, or it's related to manufacturing, or related to something theoretical. It can be something that you can witness in a small shop, like Kumbakonam Degree Coffee. and everything. The innovation is not limited to something specific, but innovation is in every walk of life. So let's move on to the topic, innovation. So what is innovation? Or as you see surrounding yourself, in which sector of industry you find that there are most innovations are there? Because you can see in your cell phones, and but specifically in which sort of industry you see innovations the most? In a report titled Innovation in the German Economy, issued by Center for European Economic Research, it has been noted that in Germany, about half, that is 50%, that 48 point you can compare to 50%, about 50% of innovation are all happening in automotive industry. And this is really huge, because the other 50% has been divided into manufacturing, food processing, and so many. So the major share of the new innovations is happening in automotive industry. And what sorts of innovations are happening in automotive industry? Automotive industry is the next question. So there are innovations that reduce cost. There are cost reducing process innovation, which these types of innovations are fairly high, because economic success is crucial in every industry. So cost reducing process innovations are fairly high when you check with automotive innovations. It came to my knowledge that one of the previous alumni has done some lectures on some stamping purpose. So there, from there you can understand that such kind of process innovations are really a must for a automotive industry to survive. So the next innovation falls in the category of digitalization. So everything we see around is now digitalized. If you want to buy some groceries, there's an app. You can just click on it and it will deliver to your household. And if you want to rent a car, if you want to rent a bike, you can speak to your car. You can set alarm in a mobile phone, and Google, Alexa, you can talk to it and they will do whatever that is digitally connected around in your household. So when speaking about digitalization in automotive sector, there are networking technologies that work inside the car or a vehicle, which help even optimizing your search for parking spaces optimizing your search for parking spaces till self-driving cars. There are many network technologies that help making your car smart cars. So many innovations are related to that. Even Google are invested in autonomous cars, and similar to other Tesla and MERCEDES-BENZ, Ford, all major automotive has done a trend in digitalization. So the third category is innovations that are meant for the overall safety on the road. Okay, so if you see, there are sensors, proximity sensors. If you get if your vehicle gets so close to another vehicle, there will be a visual warning, acoustic warning, so you can avoid a collision. So there are several innovations happening in this road safety. So totally, as a whole, when we summarize, innovations are mostly pertaining to automotive industry, and there again the innovations are categorized into three sectors: reducing the cost, and digitalization, and something related to road safety. So today I am going to discuss a case study, a problem arises due to the safety, an accident, and how an innovation helps us to improve the safety of the passenger or the vehicle on the road. So moving on to the case study. So the title of this slide is Blind Spots and How to Eliminate Them. So what is a blind spot? Imagine that you are in a car. Okay, you are started the car, and the vehicle is moving. So everything present circumstances, under behind the steering wheel, whatever you can't see is a blind spot under the existing circumstances. So that is a keep that definition in mind. Okay, so if the vehicle is in the post condition, you are not able to judge a blind spot. The blind spot is only determined when the vehicle is moving and existing circumstances, not the point. It is existing circumstances, and you can clearly define what a blind spot, but something that is not visible to your eye and your existing circumstances, whether it may be moving or the vehicle may be at halt. Okay, so that is a blind spot. Now our case study. So this is a Canadian direct insurance claim. So we can't drive vehicles without insurance on the road, right? It is purely illegal. So I don't want to go into our local cases, because in most scenarios there are people recklessly driving, harsh driving, and so many people are not obeying the laws in India. So that's why I took a global case study. So since most of the laws have been followed by the users in the global arena, so I like to take in this case study, if you observe, a Canadian driver customer, she was changing the lane. Okay, she was changing the lane, but when she checked to cross the lane, she didn't observe any vehicle behind or irrespective in her side. But when she started changing lane, she hit a car that appeared to come out of nowhere. So when the police came and registered the case, so there was no drinking or driving involved, but only she was unaware of the incoming traffic when she changed the lane. So she suffered with minor neck injuries, and there was a lot of damage to both the vehicles. So from this, we are most people's reaction is like that. The insurer's blind spot, that is that vehicle was in her blind spot. So this is a mere accident. Okay, but as mechanical engineers, as professionals, we don't believe in the theory of mere accidents. So this is not something that is unavoidable. This is really unavoidable. Only in this case, what happened is that please consider this scenario of two vehicles, a green car and a blue car. Now in the first image, if you see, the blue car is clearly in the field of vision of the green car, because in the top position you can see in the center mirror that blue car is entirely visible to the driver, but it is not visible in the side rear view mirror. And when the blue car shifts the position, in coming to the second image, when the blue car shifts the position, partially it is in a field of vision in the center mirror, as well as it is in a field of vision in the side rear view mirror. So in this third case, it is entirely in a blind spot in the central mirror, but it partially appears in the side rear view mirror. So when it overtakes, this time what happens? Only a little, 1/4 of the portion is visible to the driver. Okay, so in this scenario, I again define the blind spot. Blind spot is something that is not visible to the eye, pretend in the existing circumstances. Okay, if the driver hasn't noticed this side rear view, or think in the fourth case it was raining or it was misting or something, so that the driver was unable to see the side view mirror and he wanted to change the lane, obviously he will crash into this blue car. So this is a huge problem in passenger cars. Now let's check what are all the blind spots in a different category of vehicle. Let's say, what are the blind spots in a truck? In terms of a truck, blind spot severity is much more bigger than that of a passenger vehicle, because most of the trucks are used for long distance operations. You might have witnessed when you are going in your highways or your road, you can see heavy trucks carrying heavy loads behind them. Okay, so there are many blind spots. The driver, because the height of the vehicle is comparatively higher than that of a ordinary passenger vehicle, so the driver is unable to see what is next to him, or just immediately in front of him, because if the vehicle, or if it's a pedestrian, either it be a pedestrian or a cyclist, he's relatively smaller compared to the truck. So he is unaware, if somebody crosses him suddenly, he's unaware, and there is a big scenario of an accident or something that is said to happen. So again, if the vehicle is behind the truck, imagine if the vehicle is behind the truck, if he suddenly stops, this passenger will gets in a head-on collision with the trailer of the truck, thereby again causing a accident, and series of accidents might occur. So here this is a bad scenario, here this is a bad scenario. In this case, either side of the vehicle, let it be the driver's side or let it be the co-driver's side. At least the driver's side, if we are tilting the head, there's a chance he might have seen it, but on the other side, he's entirely completely blind. He's not aware of situation if there's a cyclist or a pedestrian is on the other side of the vehicle. So how we will overcome this blind spots in either it be truck or it be in the passenger vehicles. So how this could let us move back to the case study. So here the insurer asked for an insurance claim. Okay, but he might have got the claim, but she suffered some minor neck injuries and some more damages to the other vehicle itself. She might have got the claim, but what if that minor injuries she suffered were fatal? The insurance claim mean nothing if she could have passed away during that accident. So how we avoid something that we can't see? Okay, so this here the case study present as a serious solution, serious problem for which we need to find a solution. So how we avoid something that we can't see, something that is not visible to eye? So the term is blind spot. So hereafter, in an accident, if you refer some newspaper, if something is, if apart from drinking driving, there will be head-on collisions in which you might hear from the driver that I have never seen that car coming. You might have witnessed such cases. I have never seen the car coming, I didn't know what happened, I just hit on that pedestrian or the cyclist, I never saw him, because he was suffering from a blind spot. So the case study poses as a threat while driving, how we avoid something that we can't see. So here our Greek mythology has a solution to it. In Greek mythology, there's a evil monster called Medusa. Medusa is a serpent. So instead of her hair, she used to have serpents all over her head. And the one peculiarity about Medusa is that whoever she looks into her eye, they will turn to stone. Okay. So this is Medusa. So whoever looks into her eye will turn to a stone. Okay. So how our hero Perseus will be able to behead Medusa if he's not able to look into her into the eye. Here, Perseus has been provided with a shield, a reflective shield. So he looks into the shield, so he gets her reflection. Okay, her reflection. With this support of this reflection, she kills him. So from the Greek mythology, the problem we are having, how we avoid something that we can't see. Here, Perseus was not able to see Medusa, but he managed with the help of a reflective shield and able to behead her. Okay, the key factor is that he used here is that concept of indirect vision. He used concept of indirect vision to suit his field of vision. Okay, so in practical uses, what we use in a car and either a truck or car, we use mirrors. Okay, so the rear view mirrors are used as devices for indirect vision, but still, again in that direct insurance claim, if you are notice the picture, still we had two mirrors, not just one, two mirrors, but somehow the blue car managed to escape in between the blind spot. So that was the serious threat here, because these mirrors, either it be physical, these two mirrors, what would have how do you think what would have happened in this scenario? Let me say, the green car driver, before she started to office, she might have met with her accident when she would have started for her office. But let's say before she started to office, this car has been used by somebody else. Let's say her father used it. Okay, he is much more taller and such much more bulkier than her. So when he entered the car, he might have reoriented that seating position. He might have just pulled it back, and to adjust his line of vision, he might have tilted this side view mirror. Both the side view mirrors he might have tilted so that he can see the line of vision. So he used the car and returned it, but once he returned it, he forgot to put it back to the default condition. Now the insured claimer has entered the vehicle, and she might have adjusted seating position so that she could sit, but she forgot to use the side to tilt the side view mirror to adjust her field of vision. So in this case, even though we are having a physical mirror, a device which is used for indirect vision, still how we have met with a collision. So this is the limitation of a rear view mirror. Conventional mirror, this is the limitations. So every time we are getting into a vehicle, we need to adjust both the mirrors. Say let it be either the side left side mirror and again right side mirror. Again, if you are giving the car to somebody else to use, again they have to reorient their position according to their height and weight. Okay, so here, even though the blind spot, even though we solved the blind spot issue with the conventional mirrors, but still this conventional or the physical mirror used in the normal cars has serious limitation that again will cause many road accidents. Okay, so now in the case study we found there was a problem, blind spot, and as I'm summarizing up to this what we discussed, I'm summarizing. So let's start with the innovation introduction topic. So there are so many innovations happening in automotive industries, and these innovations are categorized into three sectors: that production and digitalization and road safety. So here in this webinar series, I am particularly choosing one topic, one case study I'm bringing up to you, that is insurance claim. A woman, she's not been under alcohol, but still she met with an accident due to a blind spot. So we provided a solution. Even though she had a physical rear view mirror, she still were not able to avoid the collision, because the rear view mirror or the conventional mirror existing presently in the trucks and the car has several limitations. So with the digital innovations, automotive manufacturers have devised and has come up with a new idea. What is that? Is that they replace a conventional mirror with a camera and a screen. What does this camera do? Instead of this conventional mirror, there will be a camera. This is rear facing. This rear facing camera will transmit the live images to the screen displayed inside the cab. Okay, so there is a digital side view mirror, or we can call it as mirror cam system. So I am taking to you. So innovation in this topic, innovation is a digital side view mirror in place of a conventional mirror, which are used for indirect vision. So in what is MCS is nothing but mirror camera system. It consists of two rear facing side cameras and a screen which is mounted inside the cabin, passenger cabin, and the model displayed here is Lexus ES 2019. This is the first ever production model that installed a mirror camera system. The concepts were discussed earlier, like in Audi e-tron and Volvo Scania. All these automotive vehicle manufacturers had the concept before Lexus, but Lexus is the first production model ever to use this one. Okay, after this Lexus, I will show you the first ever production model used in trucks. Now I will guide you to a YouTube video displaying the features of this mirror camera system in Lexus model. And excuse me for this, because this doesn't have any video. Like live stream audio is not possible via Google Meet. So excuse me for that. But I'll click on this video and you can watch the video. Thank you for watching that video. And now coming back, let me explain the features of the mirror camera system you have witnessed in this. As I said, this camera and screen replace the physical mirrors. So this the thing you are seeing right now is a rear facing camera, and the screen is installed inside the cabin side in the A pillar area. So this is an A pillar. So the screen is mounted inside the passenger cabin to the lower side of an A pillar. So what are pillars? A pillar, B pillar, C pillar are nothing but they are vertical supports of a car. So the function of a pillar here is to hold the windshield as well as the door area and support for the roof. So they provide structural integrity for the cars. So pillar overall gives a structural integrity for the car, and depending upon their position, they are named as A pillar, B pillar, and C pillar. So this is an important term in terms of automotive industry. And features of that mirror camera system. And saying about ergonomic design. Now, with the installation of the mirror camera system, the view around the car is improved with less left and right head movement. So with the installation of this screen, the driver has to tilt his head less because it is that view is readily available in front of him. As the car is going on running condition, the camera transmits live images to the screen, and due to this they have lesser blind spots, and as and there is an inbuilt heater in the camera and a luminous sensor. The purpose of a luminous sensor is to reduce the glare from the incoming traffic. Also, with the addition of this mirror camera system, now there is an extended view from the mirror. We can extend it as per our need, and also there are visual warning that shows optimal distance from the incoming traffic. And in addition to that, mirror camera system has improved the parking, because there are a couple of, if you've seen, there's a red and a blue, and this blue is the ideal condition for the nearby vehicle. So this reference lines has been a boon to the mirror camera system, so that passenger vehicles can be efficiently parked without collision with the already parked vehicles over there. So overall, the mirror camera systems in passenger cars really improves the ergonomic design, because it reduces the blind spots, and visibility around the car is very accurate with less left right head tilt movement of the driver, and there's an inbuilt heater. So even if it is raining, that the image inside the screen will be with highest resolution available, and there's a luminous sensor, so the driver can avoid the glare from the incoming traffic, so he can ride safely. So these are the features of mirror camera system when used with the passenger vehicle. So moving on to the next category of vehicle, we are moving next to truck. So what happens when this mirror camera system is installed in a truck, and how they overcome the blind spot is that we are going to discuss in the upcoming slides. So what you are seeing is Actros truck. This is the 2020 International Truck of the Year, Actros. This truck has several state-of-the-art safety systems. So they have been awarded with this affiliation, International Truck of the Year. This is the mirror camera system replacing the conventional mirror. And conventional mirror used to look like this. It similarly resembles to the ears of an elephant. Okay, this is an Actros. This is a previous year model Actros, which shows that they were using conventional mirrors before, but now the aesthetic look, say let it be the aesthetic look, or the better purview of this vehicle is something like this when a mirror camera system is installed. Okay. When it got the 2020 International Truck of the Year award, there was a special mention by the jury regarding the several state of art of the safety systems. Plus, there was a special mention about the mirror camera system, which replaces traditional exterior rear view mirror because they effectively supports the driver in maneuvering, cornering, and changing lanes. Because this, with the installation of mirror camera system, there were many challenges a driver used to face before, but those challenges were provided with the best possible solution by the installation of this mirror cam system. So again, I am going to a video which help you understand how this mirror camera system has improved the maneuverability and countering and how it helped in long distance operation of this kind of trucks. Again, similar to that, there will be no audio, but I can activate the subtitles on in this video because this is in English. So again, coming back to the slide, so I'll explain what will happen in that video. So trucks, main purpose of the truck is to carry load over long distance operations. So in this on distance operations, they need to couple their body with the trailer. Trailer is something that the truck used to carry, and the next function of the truck is to dock. Whenever once the trailer is coupled to the truck and they deliver the trailer to the particular destination, there they have to dock the trailer to the respective godowns, or let us say any facility they have to unload their goods. So here, our what does the mirror cam do? They they provide better view of the end of the trailer, so that the driver can carefully maneuver, drive, and they can carefully do the cornering. So since the vehicle length is very long, the cornering and roundabout turns in terms of truck driving is very crucial. If the driver is not able to judge the end of his trailer, it will the vehicle will hit into the surroundings, thereby causing damage to the surroundings as well as. Hello. Sorry. So in terms of truck, since the vehicle of the length of the truck is very high, and the truck has been coupled to the trailers. So once we do a cornering, or we do a roundabout, or we do the docking, or do the coupling time, the end of the trailer is a very must, so that it should be clearly visible to the driver. So he should be able to give judgments, or else it will cause great mishap. Say the truck is carrying a petroleum type of goods. So if he is not properly doing the driving, it might topple over and cause serious damage to the truck and to the surroundings. So cornering, maneuvering, and judgment about the end of the trailer are serious concerns in terms of truck drivers. So with the help of mirror camera system, now the end of the trailer judgment is better for the driver, and in cornering also they are able to do corners with a better judgment, and when compared to the conventional mirror, there are lesser blind spots. If in these two images you can see the blind spots in the conventional mirror, and as similar to that physical mirror, you can see normal view as well as a wide angle view in the displayed in the 15-inch monitor that has been mounted to the A pillar in the truck. Then again, and there are reference lines, or what we call distance lines displayed in this monitor. So the driver is well aware of the incoming traffic, and they are able to gauge the optimal distance between the incoming traffic. So if it is dangerously close, they can do the necessary adjustment when shifting from one lane to the another lane. And with the and again, one of the feature is if it is in a bad weather condition, even if it is in a bad weather condition, due to the rear camera, the driver is to have a better improved vision inside his cab. And there is also another function called monitoring function. So in long distance operation, obviously the driver has to sleep inside the truck. In this time, he is with the use of the mirror cam, he is well aware of what is happening around him without unmounting the truck. He's safe inside the cab, and he is able to judge what is all happening around without actually moving out of the truck. He's able to see with the help of the camera. Now, the next feature, this is called side guard assist. Side guard is not something and that is related to a mirror camera system, but the side guard assist works in hand with mirror cam system. So here again, I like to take the use of a video which clearly explains how the side guard assist use the newly installed mirror camera for better alerting the driver about the situation happening around him. I'm going to the video right now. Again, it doesn't have a audio as well as subtitles. So again, back to the slide. So from this video, we are able to understand whenever there's a vehicle dangerously close to that trailer, there there's a visual warning first. It appears as a yellow signal in the mirror 15-inch display monitor. Now again, if it is comes dangerously close, it comes with a red triangle with the acoustic warning. Acoustic warning means there's a beep sound, a continuous beep sound that alerts the driver about the upcoming situation. That this works in hand with side guard assist. And the next one is when when the driver takes a turn. This time, either be a pedestrian or a cyclist, he is clearly blind to the driver's vision. But with the installation of mirror camera system, they side guard assist gives a warning. Initially, it is a visual warning, and then it is a acoustic warning. Then the driver able to stop, or it stops by itself. Okay, so far I like to summarize. So we talked about what innovations happening in every industry. So innovation, as per the recent titled report from Economic Corporation of German, innovations are most in automotive industries, and there are three types of innovations between mass production, digitalization, and the safety of roads. We took an example from safety of roads. We went to a case study where a driver met with an accident due to the blind spot. So how we detect the blind spot? We detect the blind spot by indirect vision. How we do that? We obtain the indirect vision due to devices such as rear view mirrors. Again, this rear view mirrors have several limitations, but since that accident still used to happen because of the improper adjustment of the rear view mirror, there are several accidents still happen to the so we need a better innovation to provide a solution. Okay, so with the innovation of mirror camera system, again we understood what is a mirror camera system, its features, and how a mirror camera system is used in two different categories of vehicle. Category of vehicle, I meant to say a passenger vehicle and a fleet carrier. So how this mirror camera system functions serves different purpose in different category of vehicle. So far we have discussed so much things. Now you might wonder, so the last point, one more point I forgot to discuss is the aerodynamics part. uh, as I have already mentioned one of the slide, the conventional mirror as in this image used to be like an ear of an elephant, Okay, this had so they used to cause so many drag, because about some energy, mechanical energy is used to overcome this air resistance. So once we improved with that new mirror cam, the random spot checks were done. So these measurements were validated with on-road testing, and this installation has improved the fuel saving, because less energy is required to overcome the air resistance, since this conventional mirror is not in this place, and the mirror cam is used to mount on the top of the frame. So it won't hit any vehicles in oncoming traffic. So this will never hit, as well as it improve the aerodynamic when we mounted this mirror camera to the top of the frame of the vehicle, and we used to get an extended view, thereby reducing the blind spots. So we discussed all the features mirror camera system achieved in two different category of vehicle. Now getting to the detail part. So there's an innovation. We had a problem, blind spot was a problem. They had a solution, a rear view mirror. We place it with digital, we provided digital solution. Okay, so we had, it is that we understood the concept that there's a camera, we can install a camera in place of conventional mirror, thereby solving the solution. But is that enough? Because there are many rules and regulations a vehicle must abide before it is being certified to sail in a particular region. Okay, so there are vehicle regulations that automobile must satisfy to be approved. Say if it is international, there is a European. I'm mentioning Europe because Actros truck is an European model, and they're been selling in European regions and not in our regions. So international, it this whatever innovations we are doing, say it be a greener car or an autonomous vehicle, or any innovations in a car or vehicle, it must satisfy the rules and regulations pertaining to its region. So in this case, we have to follow United Nations Economic Commission, ECE, Economic Commission for Europe. We should follow this regulation, and when pertaining to national standards, India has to follow automotive industry standards and BSC. And right here we know, and all the vehicles have been switched to BARS 6, and now there are couples of regulations. These are examples. If you are doing some innovations in doors, you should be satisfying UN R11, and steering wheel, you should be satisfying R12. And similarly, all particular components of the automotive, if you are doing any innovation or a design change, you should be abiding with the particular regulation meant for that particular component. So in our case, we are doing ECE R46 regulation. This regulation is particularly pertaining to devices for indirect vision. Okay, so in companies like I work, and in companies like you prefer to work like auto in if once you have finished your engineering degree, if you like to work with any automotive sector pertaining to our research and development, mostly all work will be related to regulatory change, because you can't change the design or anything without pertaining to a particular regulation. So this is very important in terms of a student view. So you should be aware what sorts of work are happening in the companies like that I work. Okay, so this is something information I like to share with you. So for devices for indirect vision, especially the mirror camera system we are using here has to abide by the ECE R46 regulation. Now, what is this ECE R46 regulation? Okay, this is a simple concept you might have learned in your physics class back in your 8th, 9th, and 10th grades. Okay, what is an AM binocular vision? I hope most of you know, or else I can have no issues. If this 2 points, let it be OE and OD. OD is nothing but your right eye, and OE is nothing but your left eye. These are 65 mm apart. So this has been derived from an ellipse study. So right now I'm not going to in depth. I just give you a brief concept. So this is your left eye and right eye, and your individual eye provides a monocular field on your monocular field is projected to this mirror. Okay, so whatever field of vision, so let there be a tree, it will be falling to the mirror. So your both eye left eye and right eye superimpose their image on this mirror, and you are able to see this tree through this device. So this mirror device, you will be able to see this, and this is a basic concept of indirect vision. Okay, this concept we are using in physical conventional mirror. So now now the question. Okay, so how tough is to design a physical or a main rear view mirror? Because in this case you can see there are two sorts of mirrors, and they serve different purpose. One is for normal view and this is for wide angle view. So the thing is that if the mirror is flat, the images are pretty clear, but it constrains your field of vision. So to improve the field of vision, you have to increase the radius of your mirror. Spherical radius you need to increase. Once you increase the spherical radius, what happens is that the images get distorted. Like that, you will not be able to judge whether the mirror is closer to you or a little bit longer to you. Okay, and again, the wider angular view mission has a increased spherical mirror compared to this normal view. Okay, so constraints should keep in mind that this physical mirror should not exceed more than 230, around 230 mm. They should not exceed the width of the vehicle. That is the first constraint. Once you place this mirror, it should be able to obtain. So there are certain classes of field of vision. There are around 5 to 6 class field of vision. So every category of vehicle must retain this field of vision. So as you increase the spherical radius of mirror, the images get distorted and you will not be able to judge the practicality, means the practical how near it is to you or how it far it is you. So there are certain criteria. So it is like a mix. So it is a little bit difficult. You should not go you should not increase too much, or you should not go too low. If you go too low, you will not be able to get the field of vision inside the mirror, thereby creating more blind spots. But in case you increase the spherical radius, what happens is that the image get distorted and you will not be able to judge how close the incoming vehicle towards your trailer. And again there are several category of vehicle. Let it be a bus, minibus, or truck, or a pickup truck. There are this category of vehicle. For each category of vehicle, this regulation has defined certain field of vision. For let's say if I am choosing a car, okay, if I am choosing a car, it must satisfy class first field of vision and class 2 field of vision. If I am going to a truck, it must choose first class field of vision and second class field of vision, then third, then fourth, then fifth, then sixth. There, depending upon the occupancy and depending upon the tons weightage, okay, you need to satisfy certain criteria. This criteria as mentioned in the EC regulations. Okay, so whenever you design a physical mirror, or you are bringing up an innovation in any component in your automotive, there will be a particular or a peculiar particular vehicle regulation that you must satisfy. So there will be so in this case, this is an example, like this main mirror, there will be several criteria for the door. Say in the door, the thickness of the door should not exceed 1 mm. The thickness of the door should be less than, the sheet should be less than 1 mm. So there are so many criteria. So in this case, that the mirror should not exceed 230 mm, and the spherical radius should not go 600. If you increase the 600, if you increase this, if it is in the higher side, the images is distorted and you will not be practical to judge the incoming traffic. And depending on the category of vehicle, there are several field of vision. So you have to choose your category of vehicle first, then you have to define the field of vision. And the field of vision is obtained by this calculation, binocular vision. And this is just example. I don't want to just I will explain the class 1 field of vision. So this is a driver's eye point, driver's ocular point. So 60 meter behind. So this driver should be able to see. In class 2 and class 3, the driver should be able to see things that are from far 4 meter and 30 meter, and this field of vision should fall into place. Again, there is a difference for class 3 and 5 and 6, so on. So I don't want to go in depth, but generally, if you are bringing up any innovation, you should be abide by the vehicle regulations. And let me summarize the whole. We started with innovations in every walk of industry, and there are more innovations in automotive industry as per the title report from German. And there are 3 type of innovations in automotive sector, that is process innovations, and then road safety, then digitalization. So we took, and in our this presentation, I took a case study pertaining to blind spot. So how we solve a blind spot? We solve a blind spot by a indirect vision devices. So what is indirect vision device? Indirect vision device is nothing but a mirror. It's a rear view mirror, but this rear view mirror has many limitations. If it is not properly adjusted, the driver will not be able to see the incoming traffic and thereby causing accidents. So we provided with one digital solution, that is digital side view mirrors. So in this case, there is rear facing cameras and a screen, and it helps us to be it's a built-in, they have a built-in heater and a luminous sensor, which in any type of weather condition we are able to see. And again the same mirror camera, what is the use of same mirror camera system? Same innovation, 2 different category of vehicle. We firstly we discuss passenger vehicles, then we discuss trucks, and compared to passenger vehicles, there are more beneficially in truck, and we discuss about Actros truck, which is the 2020 International Truck of the Year, and it improved the so many functions that the truck has to carry out, like docking, coupling the trailer, and avoiding accidents, and then monitoring and rest, and then that fuel saving, and then we came to the vehicle regulations. If you are doing innovations in any topic or any component in automotive, you should abide by its vehicle regulations. We discuss some criteria or pertaining to our devices for indirect vision. So that is a summary of a whole presentation. And now so this is an Actros truck, and I'm standing in front of it, so you can see how small I am in front of an Actros truck, and almost I am blind to the driver who might sit inside the cabin. So that's all for today, and I thank you. And today is June 21st, and it's the International Day of Yoga and Father's Day, and again it's a World Music Day, and it's the longest day of the year. There are so many specialties for the and June 21st today. It's the International Hydrography Day, and again a book, Order of Phoenix of Harry Potter, has been released in the same date back in 2003. And that's for all today, and I thank you for and any questions if you have to ask, please shoot. Hello.
Participants, if you have any question, please ask. Otherwise, you have to send the detail in the chat box.
Yeah, hi, this is Madhu here.
Okay.
Yeah. Hi, Aravind. It's a good presentation. Like I'm one of the alumni, passed out in 2007 at FX, and currently working at NASCOM. So it's a really good, presentation. So like I am not having any questions per se, but I would want, each and everyone was present there to ask for questions actually, because I think more than the session, I think you should all try to understand that how you can get into places like MBRDI. So I request each and everyone to come on board.
Sure, sir. Sure. Hello, sir. Hello, sir. Hi. I'm able to see you.
Aravind, it was a very wonderful session, Aravind.
Thank
I
you.
hope we might be able to, you would be able to recollect me, I think.
Yeah,
I'm
sure, sure,
Aravind.
sure, sir. I know, sir. I know,
So,
sir.
yeah, I'm from CSC department. It was a very wonderful session. Thank you so much for coming and sharing. And sharing your videos and also about the blind spot and everything. It was very interesting. So please do join for our alumni association activities in Bangalore also. And
Okay, sir.
once again, thank you so much for this same love and regards to all at home. And God bless. I think Kumar sir is also here from
Yes, sir.
our director of alumni association. I think I also request him also to share a few words.
Okay, sir.
Thank you, Arvind sir. Arvind, it was a wonderful session, and today only I came to know about understand the driver blindness and all the innovation in the automobile industry, and it's eye-opening for all the students as well as the faculty. And thank you for the wonderful webinar. Thank you, and thank you, Madhu, also.
Thank you, sir.
Thank you, sir. Hey, Aravind, just would like to connect with you as well offline. Maybe like you should be part of the Bangalore chapter.
Okay.
So I hope I can take your number from Aravind sir, right?
Yes, sir. Yeah, he might be having my number.
Okay,
Tanu sir and
wonderful.
Ayana sir is having my number.
Okay, wonderful, wonderful. So you are based out of Bangalore?
I'm based out of Kerala. I'm presently working in Bangalore.
Okay, yeah. So and tell me one thing, like what is the one thing which you want to leave it with the students who are here, like how should they prepare to be part of the OEM?
To be part of the OEM,
Post their college studies.
they should be very there are design tools like CATIA and NX UG. They should be well versed in that. So once they go to some walk-ins, if in their resume they are preferably they choose for candidates with knowledge in that particular design tools, because
Okay.
that in most R&Ds we use this CATIA and NX. In MBRD we are using NX, and for German teams they are using CATIA.
Okay. So see, one point is about the tool per se, but like what is that they should you see, it's knowing the tool may not be that's one part of it, but like what is that like they should know? Is that the physics they should focus more, or
Yes. In that case,
materials they should focus more, or
manufacturing, sir, especially the manufacturing part, they should be well versed, and because manufacturing is a key for design. You can't design something without you are not knowing anything about the ABCD of even if you are not unaware of the tool, that is fine, because within a week or so we can learn with on-job training. But
right.
manufacturing is a very key point in if you want to choose to be in automotive sector.
So, is there any reference material or something like that? If you can feel free to share it with the students, that will be really helpful for them as well.
Yeah, sure. I'll share with Aina, sir,
Yeah.
later.
See, like fundamentally, like I want. I think currently 35 people are there. At least minimum, 35 should get placed into OEMs when they come out of colleges.
Definitely. I wish all the best for the students.
That's
So
that's the support what we can provide to them.
yes, sir. Thing is that nobody should lose hope, because if I can make it, definitely you are far more smart than me. So definitely everybody can make it. So it's
Wonderful.
because
I
hard work
spoke
always
to.
beat talent.
Yeah. Okay. Good. I spoke to Manu Saleh this Friday.
Okay. Oh,
Good to know, Arvind. Thanks a lot. Thanks for
thank you.
joining.
Thank you.
Thank you, Madhu, also for joining, Madhu. Thank you so much, Madhu, for joining.
Yeah. Welcome, sir. Thank you so much.
Thank you, Aravind.
For your wonderful session. Thank you
Thank
for
you.
joining us alumni meet.
Okay, sir. Thank you, sir.
Thank you, Aravind, once again. It was a very wonderful session. Thank you so much. Thank you, Ainar Raj, sir. It was also wonderfully organized. Well done, sir.
Thank you, sir. Thank you. Thank you. Thank you, participants. Feedback link sent to your registered mail ID also in the chat box. Thank you so much for all the participants. Thank you. Thank you very much.
Thank you, Kumar, sir, for joining.
Thank you, Arun sir.
Thank you, sir.
Yeah,
Thank you,
thank you, Arvind.
Thank you,
Thank you, sir.
Kumar.
Thank you, sir.
Thank
Thank
you.
you. Bye. Bye. Sir. Bye.
Bye-bye.
Thank you, sir. Thank you, Aravind. The presentation was very nice.